Yes, sir.
Yeah, please answer.
Yes, sir.
See, yeah,
Yes, sir. Yes, sir.
two length. Pardon?
Yes, sir.
One. You take these as assignments. Two length compensation, fixed zero, fluid zero, absolute, and incremental. And the next one, two length compensation over and fixed zero, fluid zero, and NC motions. It is point to point, straight line, interpolation, and the contour, NC motions. The next one, the last important thing is advantages and limitations or disadvantages of NC machines or NC technology. Okay, or you can say NC technology. So please make you among them 100% I'll be assuring you there will be one question from this in VTU examination. VTU examination, one question will be there from this one. Please remember this. Okay. And after this, let me come to the part programming, manual part programming. In the manual part programming, this is a method of preparation of the program. The programmer is going to write the instructions, okay, that is called as a special part programming manuscript. And the manuscript the programmer is going to prepare will be varying from machine to machine. You have seen that the 2-axis drilling machine, 2-axis milling machine, 3-axis milling machine, 3-axis drilling machine, and even the 6-axis milling machine, all these are available, and the method of writing the manuscript for all these machines will be slightly different. Okay, the program has to undergo the training for all these. Okay, and while he is going to give write the manuscript, he will be mentioning the tool movement. He will be mentioning the tool movement in the manuscript in order to do the machining. At the same time, he is going to write some kind of programs which will be controlling the activities of the machine tool. For example, the spindle has to rotate in the clockwise direction, the spindle has to rotate in the counterclockwise direction, the coolant should be on, the coolant is off, okay, and the table movement and the tool movement, all these together in series he is going to write the program, the instructions which he is going to write, that will be replicated or those will be taken as instructions by the machines. So this is the manual part programming, okay. And here you can see small machine which I have shown, okay, in order to make you to generally understand what is the table, what is the tool, what is the spindle head, what is the column, and what is the x-axis, y-axis, all these have been given here. You can see this, okay, you can see here. And the next, let me come to very important thing. Each one of you please kindly remember, unless without these we cannot write any programs. We cannot write any programs. And there are basically codes. Okay, there are basically codes. We are called them as G codes and M codes. Very important. Okay, and let me come to the M codes. These are called miscellaneous codes. These are called miscellaneous code. And these miscellaneous codes will be used for the functions like subprogram, calling and exit. What is the subprogram? We are writing a main program. For example, I am going to write a main program. Please understand what I am going to do here. I have two workpieces, for example, and I have two workpieces. These workpieces shapes are different. Okay, and here I need to do drilling of similar kind. Drilling of similar kind. Now what the programmer can do is, for this part 1 and for this part 2, all these preparations he will be doing the program, and while he is going to do this drilling operation, this particular program will be written in the separate sheet, and that will be called into the main program, that is called subprogram. We are going to call them, and subprogram exit. Correct? No, because on many different parts we may have to repeat the similar kind of drilling operations, having the same pitch and having the same drill size and having all these same parameters, and that time we can call this particular program as a subprogram, or we can include this subprogram into the main program which are written in this. So subprogramming we are going to call and exit by using the M codes, and we are going to give spindle clockwise direction or counterclockwise direction rotation. For this also we are going to use, and we are going to use for coolant on off, for the coolant on off, and another one for the program end, etc. We are going to use this M codes. M codes will be used. Okay, and let me study the M codes later on, and let me come to the G codes. And the G codes are very important, and these will be instructing the tool movement. Tool traversing along different axes. That will be done by G codes. That will be done by G codes. So these G codes you have to remember. Please remember the first one I will be writing it G00. G00 is rapid positioning. What is this rapid positioning? For example, the home position of the tool is here. Home position of the tool is here. And this is the working table. I want to traverse this tool from this position to this position, come here. Then after this we are going to do the machining like this. And here you can please look here, the tool you are going to move from here to here, from the home position to the initial position of the cutting. That movement we are going to do, that can be rapidly taken without having any kind of control, without having a consideration of speed, feed and depth of cut. Just the tool will be rapidly moved to this position. It will be positioned. That is called rapid positioning, and it is represented by 000. You understood? All of you, please, one of you unmute. One of you unmute.
Yes, sir.
You understood it? G00, these are very important. Why I am telling. Okay, G00 is rapid positioning. Okay, the second one is the linear interpolation. Or simply I'll show this. Linear interpolation, this is G01 is linear interpolation. So unless you remember them, you cannot do any program. Linear interpolation. Okay, linear interpolation is, this is linear interpolation. G01, it is taking the linear movement is a linear interpolation. And the next one is G02. G02 is circular interpolation clockwise. clockwise. So that means rotating the tool, please look here, while the tool is rotating, the tool, what happens to the tool will be rotating the clockwise and it will be interpolating. That is called a circular interpolation clockwise. And in other way, you can see here, I'll show here, this particular work part, and you say it is the tool radius we have selected, the path of the tool. This is the path of the tool. Earlier, for example, this was the home position and it has traversed to this point, or it has traversed to this point, it has come here. And now it is moving this point, and you can see that it is rotate from here to here, this segment, it is circular interpolation clockwise. Correct? No? Circular interpolation clockwise. And if you are going to move like this, the circular interpolation counterclockwise. That is the thing what I wanted to tell you. While doing the program, you will come know little more. And next one is G03, it is circular interpolation counterclockwise. And the fifth one, I will be giving you G04 is a dwell. Dwell is simply it is moving from here to here without cutting any or without doing any kind of machining. That is dwell. And another one important things are there, G20 and G21. G21 and in this one there are the G codes which will be controlling, the input will be in terms of inches, and if the input you are going to give in terms of mm. For example, a particular work part is given to you and unfortunately the dimensions given are in inches, and the programmer, if he has to convert these inches into mm, it will be a tedious job and small variation in the dimensions will happen while doing the conversion, so that the CNC machine can be ran in mm or you can run in the inches. So by using the G20 and G21, we can go for the program the input in terms of mm or input in terms of inches. Okay, if it is given 20, it will be understood that it is 20 mm if you have taken in terms of mm. Okay, everywhere it's not required to write the mm. And G28, and return to reference point. You are going to return back to the reference point. All these please remember. And G40, cutter compensation cancel. Cutter compensation cancel. And G41, it is G40, okay, G41, cutter compensation to left. And next one, G42, cutter compensation to right. See the interest you are going to show. You are not asking me what is this cutter compensation to left, cutter compensation to right. Anyone please tell me what is this cutter compensation to left or cutter compensation to right? Anyone know it? Anyone?
So right hand cutting or left side cutting up.
Yeah, please look here. Some of the things you should not imagine. For example, this is the cutter path. and I am going to use this. Let me rewrite once again. Look here. I want to do this machining. And this is the cutter movement. Cutter is traversing the path. Now, please look here. And this side, this here, the cutter compensation has to be given to the left, because from the axis left side portion of the cutter is in action in cutting the machine, the material. Correct, no? And here in this case, you can see that this to the axis, the right side portion of the cutter is in action in removing this one. It is cutter compensation to right, and it is cutter compensation to left. Cutter compensation to right, cutter compensation to left. Because from the axis, if it is which portion of the cutter is involved, so the right portion of the cutter is involved, so definitely G42. And here if the left portion of this is involved, it will be G41. The cutter compensation to left and cutter compensation to right. Okay, and once you remove the cutter compensation, what happens? The tool axis, the cutter will not be taken into account. Please understand, cutter compensation, if I keep the cutter compensation, for example, this is a 5 mm movement, then definitely 10 mm cutter will be used. 10 mm diameter cutter will be used. And if you are going to change this, what happens? The axis will be shifting from here to here. So that is what the G41 and G40 and G42. Cutter compensation cancel, cutter compensation to left, cutter compensation to this one. And the next one, the two length compensations, how the two length compensations will be given. So G43 and G44. It is two length compensation. It is positive way, and the two length compensation a negative way. Okay, these are the two emphases. And the two length compensation, if you want to cancel, then G49. It is two length compensation cancel. We are going to cancel in the two length compensation. Okay, G49. And the sometimes what we are going to do, what is the meaning of peck drilling? Please, one of you please tell me, peck drilling. Whatever you know, please tell me. It is not a big problem. See, look here. I have a material. I have planned to do a drilling in this. For example, I want to do the drilling up to here. What we are going to do is, initially the tool will be taken, it will be moved up to here, and again it will be taken back. Again it will be moved inside, it will be moved up to here, again it will be taken back. And again it will be moved up to here, and again it will be taken back up to this position. Like that, the tool will be moved up and down. That is called peck drilling. So that means we are come up to here, then again go up, and again come up to here and go up, and again come up to here and go up, and come up to here and again go up. So this peck drilling, what happens? the peck drilling, what happens? Whatever the scrap is formed inside, that scrap will be removed through these fluids, and it will be making a discontinuous chip, and the tool life will be increased. So this is called peck drilling. Peck drilling is what just you see here. I am going to just I'll show. Look here. I am moving up to here and again going back. Coming up to here and again going back. And coming up to here and going back. That is, I am going to do the peck drilling. While doing this peck drilling, what happens? The chips formed will be discontinuous and the tip of the tool will not